Hi, I am Sanjay Patel. In this video, we are going to solve problems on successive differentiation based on the formula number 8, 9, 10, 11. Okay. In our previous video, we have discussed some problems based on the formula 1 to 7. Okay. So just remember this. If y is equal to sin ax plus b, then its nth derivative yn is a raised to n into sin ax plus b plus n pi by 2. And the formula for cos is also same, just replacing sin by cos. You don't have to remember anything new. And if we have this combination, multiplication of e raised to x, e raised to ax and sine or cos function, then we have these two formulas, 10 and 11. It says if y is equal to e raised to ax into sin bx plus c, then its nth derivative is given by r raised to n into e raised to ax into sin bx plus c plus n phi. Here, this r and this phi, these two things are given by these relations. R is given by square root of a square plus b square. What is a and b? A and b are here. A is here in the, it's a coefficient of x in the power of e, and b is here in the coefficient of x as in the sine function's argument. So we have to find a and b and find the value of r then, that is square root of a square plus b square, and then we can find the value of phi using these two equations. A is equal to r cos phi and b is equal to r sin phi. Okay, so let us discuss our next problem. So far we have solved 4 problems. Now this is the next one. So I'm starting with the problem number 5. So if y is equal to sin 5x into sin 3x, then find the value of yn and yn0. Okay. So let us solve this. This is not in the standard form. We do not have any formula for finding nth derivative of product of sine into sine or sine into cos. So we have to convert this expression into some of the known formula form. So what I do here is, let us start with the given function and try to express in terms of only sine or cos. And remember, there is no e raised to x function. So we have to use only those two formulas, that is nth derivative of sine ax plus b or cos ax plus b. This I can write as y is equal to, let us multiply and divide by 2, because we know the formula for sine 2 sine alpha into cos, sine alpha into sine beta. Okay, let us recall that formula. All of you know, if you have 2 sine alpha into sine beta, then we can write it as cos, we can write cos of alpha minus beta minus cos of alpha plus beta. C minus C is minus 2ss, but we are writing in this in the reverse order. Okay, so applying that, here alpha is equal to 5x and beta is equal to 3x. So this gives us y is equal to 1 by 2 as it is into 2 sine alpha sine beta gives us cos of 5x minus 3x. So cos 2x minus cos 5x plus 3x, that is cos of 8x, just using this formula. Okay, now this is in the standard form. This is cos ax plus b form, and this is also cos ax plus b form. And we know that if we have this if y is equal to cos of ax plus b, just we are writing that formula so that you can understand, then yn is equal to a raised to n into cos ax plus b plus n times pi by 2. So using this formula for both of this, for taking nth derivative, So from this equation, let us call this as 1. From 1, I can write yn is equal to this 1 by 2 as it is, and nth derivative of cos 2x, where a is equal to 2 and b is equal to 0. So it is 2 raised to n into cos of 2x plus n into pi by 2, minus for the second term, that is cos 8x, we have a is equal to 8 and b is equal to 0. So it is 8 raised to n into cos of 8x plus 0, that is nothing, into plus n times pi by 2. So this is the nth derivative of the given function y is equal to sin phi x into sin 3x. We can also find the value of yn 0 by putting x equal to 0. That is, at x equal to 0, we have yn of 0 is given by 1 by 2. So wherever x appears, we substitute 0. So it is 2 raised to n into cos n pi by 2 minus 8 raised to n into sin n pi by 2. So this is the answer. Okay. This value of cos n pi by 2 can be anything. It can be 0 or 1 or minus 1 depending on the value of n, where n is any natural number. Okay. Let us go to the next problem. This was very simple. Just simple use of trigonometry. So consider the next problem. Number 6. If y is equal to sin cube x, then find the nth derivative, yn. Find the nth derivative, yn. Okay, let us solve this. So first of all, again this function, y is equal to sin cube x, is not in one of the standard form what we have studied. So we'll convert this into some function which is not involving sine raised to something, because we have the formula for y is equal to sine ax plus b only. How this can be converted? For that, we can use again some simple trigonometry. We have the formula for sine 3x or sine 3 theta. It is equal to 3 sine x minus 4 sine cube x. This you have studied in your school. So from this, I can make this sine cube x as a subject of the formula and write it as sine cube x is equal to sine, let me write this way. This I am keeping, this I am taking on this other side. So it is 4 sine cube x. I am writing directly. This is equal to 3 sine x minus sine 3x divided by 4. First you can take this on this side, other is left hand side, and sine 3x on this right hand side, and then divide by 4. So you will get this 3 sine x minus sine 3x by 4. So we can write this function sine cube x as 1 upon 4 times 3 into sine x minus sine 3x. So taking nth derivative on both the sides, we get yn as yn is equal to 1 by 4, and this 3 is a constant in multiplication as it is, and the formula of sine ax plus b we are going to apply for this sine x, where a is equal to 1 and b is equal to 0 if you compare with y is equal to sine ax plus b. So it is sine of x plus pi by 2, sine of x plus n times pi by 2, and minus, here a is equal to 3 in this second term. So we get 3 raised to n into sine of 3x plus n pi by 2. Just recall that formula, that y is equal to sine ax plus b is the given function, then its nth derivative yn is a raised to n into sine ax plus b plus n pi by 2. So we are using this formula for both the derivatives of these two terms. Okay, so this is the required answer. Okay, let us go to the next problem. So from this set of problems, you'll understand how to think in different situations. Let us consider the next one as if y is equal to sine square x into cos cube x, then find yn. Find yn. To solve this, again, first we have to write the given function in the standard form. Here there is a sine square x into cos cube x. So let us use some technique to simplify and remove the powers of sine and cos and get simply sine ax plus b or cos ax plus b type expressions. Okay, so what I am going to do here is first let us consider this as y is equal to sine square x into cos square x into cos x. So I am splitting this cos cube x into cos square into cos x. Now we know that sine 2 theta is 2 sine theta cos theta. So in order to get sine 2 theta over here for these two terms, what I will do is I will need to multiply this sine square into cos square by something so that I can use that formula. And since it is square, we will multiply and divide by 4. So this I can add as 2 sin x cos x square. So this 2 square, that is 4, will be cancelled with this into cos x. So this gives me 1 by 4 times sine 2x square into cos x, because sine 2 theta is 2 sine theta cos theta. Okay, now still the square is there, so I can remove that square that by using the formula, because this is same as sine square 2x into cos x. Okay, we know the formula for the cos 2 theta. That will be helpful in this case because it involves sine square. Cos 2 theta is 1 minus 2 sine square theta. So from this I can write sine square theta is equal to 1 minus cos 2 theta upon 2. Okay, so if theta is here, we have to write its double, that is 2 times theta on this right hand side. So this is sine 2x, sine square 2x. So that I can replace by 1 minus cos 4x upon 2, and into cos x is also there. There are many other ways you can simplify and try to remove this square and cube. So let us go further. Now I can write this as y is equal to 1 by 8 into multiplying by cos. So cos x minus cos 4x into cos x. Okay. Now separating this and writing as 1 upon 8 times cos x and minus, again for this I want to use that cos alpha into cos beta formula. So I should have 2 here. So let's multiply and divide this term only by 2. So what I will get is 1 upon 16 into 2 cos 4x into cos x. Just note that I multiply and divide by 2, and that 1 upon 8 is multiplied with this, so it becomes 1 upon 16. So this I can rewrite as 1 upon 8 into cos x minus, now 2 cos alpha into cos beta is cos alpha plus beta, that is cos 5x plus cos alpha minus beta, that is cos 3x. Okay, so now everything is in the standard form. All terms are in the form of cos ax plus b type function. So this gives us y is equal to 1 upon 8 into cos x minus 1 upon 16 into cos 5x minus 1 upon 16 into cos 3x. Okay, so taking nth derivative now on both the sides, we get, taking nth derivative, we get yn in the left hand side, that is equal to 1 upon 8 nth derivative of cos x function. So that I can write directly as cos of x plus n times pi by 2, because derivative of cos ax plus b is a raised to n into cos ax plus b plus n pi by 2 according to that formula, minus 1 upon 16. Now for this term, cos 5x, a is equal to 5 and b is equal to 0, so it is 5 raised to n into cos of 5x plus n pi by 2. And finally, for this we have a equal to 3 and b equal to 0, so minus 1 upon 16 into 3 raised to n cos of 3x plus n pi by 2. So this is our final answer for the nth derivative of the given function. Okay. Now the next problem is based upon this is the problem number 7. The next problem I am going to take as problem number 8, and that is, if y is equal to e raised to x into cos 2x into sin x, then find the value of yn. Then find yn. Let us solve this. We have y is equal to e raised to ax into cos 2x into sin x. We'll try to convert in the standard form, and which is either e raised to ax into cos bx plus c or e raised to ax into sin bx plus c. Let us see. Here we have y is equal to e raised to x into cos 2x into sin x. Okay, this we can write as y is equal to, that is, multiply and divide this by 2. So what I will write here is e raised to ax by 2 into 2 cos 2x into sin x. So we have a formula for this, 2 cos alpha into sin beta. And what is that formula? That formula is 2 cos alpha into sin beta is given by sin alpha plus beta minus sin alpha minus beta. So this gives us y is equal to e raised to x by 2 into sin alpha plus beta. Alpha is 2x and beta is x, so sin 3x, and minus sin alpha minus beta, so sin 2x minus x is sin x. So this now is in the standard form, because I can write this as 1 by 2 times e raised to x into sin 3x, and second term also as e raised to x into sin x. So both of these terms are in the standard form of that y is equal to e raised to ax into sin bx plus c. And let us write down that formula. We know that we have the formula for y is equal to e raised to ax into sin bx plus c, then yn is equal to r raised to n into e raised to ax into sin of bx plus c plus n into 5. Okay, here this r is given by, as you know, it is also given in that formula, square root of a square plus b square, and the value of phi is obtained by these two relations. A is equal to r cos phi and b is equal to r sin phi. Or you can also write, say phi is equal to tan inverse of b upon a. If you divide b by a, you will get tan phi, and that will give you the value of the argument phi as tan inverse of b upon a. Okay. Now, for this result number 1, let us take nth derivative on both the sides. So, taking the nth derivative in result number 1, taking nth derivative in 1, we get yn, the left hand side derivative yn here as 1 by 2 as it is into e raised to r raised to n. See, for this first term we have, let me write here, a is equal to 1 and b is equal to 3. So r is equal to square root of 1 plus 9. So it is square root of 10, right? Square root of 10. And what is the value of phi? Phi is given by tan inverse of b upon a, that is 3 upon 1. So we can now write down using this formula, putting r is equal to root 10 and phi is equal to tan inverse 3 for this first term nth derivative. So what I get here is r, that is root 10 raised to n into e raised to ax, which is x, into sine bx plus c, that is 3x only, plus n times phi, and phi is tan inverse of b upon a, that is 3 only. This is tan inverse, it is tan inverse of 3. Okay, that is first thing. And minus 1 by 2, let me write this second derivative, second term derivative of order n is minus 1 by 2, multiplying this 1 by 2 with this term, we get minus 1 by 2. And in this second term, if you compare with this e raised to x into sin x with this formula, we have a is equal to 1 and b is equal to 1. So we have r is equal to square root of a square plus b square, that is square root of 2, and phi is equal to tan inverse of b upon a, that is 1, and nothing but pi by 4. So here we are getting the value of pi, but here the value of pi is value of phi, but value of phi is not known in this case. So for the second term, I can write it as r raised to n, that is root 2 raised to n into e raised to x, as it is, sine bx plus c, that is only x, and into n phi is pi by 4. So this is our nth derivative of the given function. So this way you can find the nth derivative of some functions involving sine and cos. Okay. So this with this we end this lecture, and in the next lecture I am going to discuss problems based on Leibniz theorem, and that will be very, very interesting. So thank you.